Hello everyone, Team FaceCraft is excited to present our project, a generative adversarial network based on the StyleGAN 2 research paper. My name is Ethan, and my partners on the project are William and Timoteo. Together, we have been working on creating a generative model that can create human faces from random noise. Let's start by explaining Hugging Face, where we are hosting the model. Each time a user wants to generate a face, they need to run the model in Hugging Face, where we are hosting. This allows the user to send in either a prompt, image, or random noise to generate a human face. To accomplish this, we need to upload our trained models with the configuration files, which allows the sites to run necessary computations when the user enters a request. The model then returns an image to the user, where the user can either save the image, do a new generation, or exit. Let's walk through some of the features of our model. First, we have the ability to generate an image from random noise. This is the backbone of our network. By clicking this button here, we can generate an image from random. As you see, it has generated a random face from our model. If we go and want to do a new generation, and we click the same button again, it will generate another random face. And we can keep going as many times as we want until we find a face that we like. Next, let's generate a face from a prompt. I'm going to type an old man with gray hair and click prompt generate. And as you can see, it generated an old man with gray hair. Let's do a young woman. And just like that, it generated a woman, but it wasn't that young. Girl, I should say. And you see we have a young woman. We can generate it again to see if we can get anything close to what we're looking for, like a child. You see, it just keeps generating new and new faces. Moving on, we can generate from a image. So image generation. By clicking here, you can upload our image. I will upload a picture of myself, and it will try to generate an image based on this uploaded image. As you can see, it has generated an image that tried to match my look. We can do it again by uploading a different image. For example, if we upload a non-human, let's say Will's dog, it will try to make a human based on the image that's inputted. So we could be expecting a person with brown hair, maybe brown eyes. And as you see, this is what it thinks Will's dog would look in real life as a person. Moving on, we're going to show you our settings feature, where we can change the numerous outputs in many different ways. Starting off, we can change the number of images that are generated. We'll switch this to 4 and do a random generation. And you can see it generated 4 random people. So if you want to speed up time, you can easily just keep clicking through to easily find an image that you're looking for. We can also change the model from when we first started training at epoch 1. If I'll do 2 images. You can see how it looked back when we first started training. And if we progress to see epoch 40, you can see how the model is learning over time. Epoch 86, epoch 120, and our current model 140. You can change the image resolution. Default, it's 256 by 256, but you can go to 1024 by 1024. I'll switch this to one image and do a random generation. If we open the image in a new tab, we can see up here the image is 1024 by 1024 versus image that's 256 by 256. If we open a new tab, it's also a lot smaller. Next, we have filters like cartoon, pencil sketch, watercolor, X-ray, black and white, sepia, and blue tone. Let's do a cartoon, X-ray, and black and white filter. It will give you the original image, the cartoon image, the X-ray image, and the black and white image. You can do that for a number of images. If we do 4, it will do this for all 4 images. You can also remove the background if you just want the face. As you can see, it did head segmentation, removing the background, so where you only have the head. If you do it again, you can easily crop the image if you need only the head. Last but not least, we have an option to manipulate the image's latent space. Let's do a random generation and move the slider to the right. As you can see, it is slowly changing the image over time through its latent space. If I go all the way to the end, you can still see some of the features, like their nose, where their eye was, their head shape, their neck, and their body, and their hair. If we move all the way back to 0, or close to 0, you can see the person coming back to life. Thank you for watching this video, and we hope to see you next time.